Really, it's my pleasure today to give a little bit of a scientific background on what types of data Carbon Mapper is providing and what are the main scientific questions we're addressing. And to do that, I want to define this key feature, which is how do emissions manifest in many places globally, especially in anthropogenic sectors, so like oil and gas, waste, and agriculture. And in these sectors, there's this differentiation in terms of two broad categories. And one of them is an area source and the other is a point source. First, just look at this figure we have on the bottom right. You see this oil and gas basin, lots of dense infrastructure. Each of those pieces of infrastructure where there's gas extraction may have some sort of emission. Small seams here and there can lead to small emissions. In aggregate, across all of that infrastructure, it makes up an area source, right? The total flux, the total emission that might be coming from that basin. But what's really key, and what we found repeatedly over multiple surveys, is there's this other feature called super emitters or just point sources. And what these are disproportionately large emission sources that might occur in a basin. And why these are important is that these point sources or these super emitters can be quite disproportionate in terms of the total emission contribution. So with that in mind, with that definition, we really want to get to why are we addressing methane and why are we addressing methane super emitters? So methane itself is a much more powerful greenhouse gas than carbon dioxide. In fact, probably 86 times worse over a 20-year time scale. It's also short-lived in the atmosphere, meaning that if we reduce methane emissions, we can actually see the climate benefit of that within our lifetimes. And in particular, these super emitters can be quite effective at reducing the methane emissions if we target them. So the question is, what types of observations do you need in order to address it? And so what we have here is a picture of a global distribution of fossil fuel methane emissions. And what you can see from this figure is that they occur all over, right? It's not just the US, Europe, it's every continent. So you need a global strategy that can do a few things. And one of it is a global monitoring solution. You also need to do it with high frequency. Methane emissions can be quite variable. So you need to have a monitoring solution that has regular revisit as well. And you need to have it that is high sensitivity. And again, that's where we're focused here with Carbon Mapper. That's where we're moving towards with our technology and our portal to be able to track this system. What we use here to basically design that observing system is built on the foundations of imaging spectroscopy. Maybe another diagram that shows how this is done in practice is this one here. We have a satellite that is scanning the Earth. So you imagine this picture on the bottom. Imagine that satellite's moving in that flight direction. And as it scans the Earth, it observes solar backscattered radiation, not just in the visible spectrum. It's looking at a lot of different wavelengths. So that includes the near infrared as well as the shortwave infrared. And in the shortwave infrared, methane and carbon dioxide are very strong absorbers of solar backscattered radiation. So as the satellite is moving across this path and it is measuring what's happening at those shortwave infrared wavelengths, if it detects an anomaly in terms of absorption, that can be translated to a methane concentration and actually to a methane plume. Some methane emission sources are quite variable and they're quite intermittent. But what we do on our portal is we say, well, let's try to take the characteristics and the dynamics of the plume over a time period to try to constrain total emissions, meaning a detection, a non-detection, and a detection, again, we will create a metric called persistence, which is the number of detections divided by the total number of observations. And we use that when we quantify what the total impact of emissions from that source is. So when you're looking at the portal, all of these sectors, in a global sense, we have seen evidence of super emissions. And this is the types of data sets that you can anticipate and can anticipate to grow with additional observing that we're doing at Carbon Mapper.
Hi, everyone. I'm Alex Diamond, Director of Products and Engineering here at Carbon Mapper. What you see here is our data portal. So this is our sources overview. It allows you to kind of scroll through an infinite list of all of the global sources worldwide. I can sort this by the acquisition date, the published date of the particular plume, or by the emission rate. We'll go ahead and search for location in Iran. This is a gas processing facility, but you can see this plume here, and I'm going to go ahead and open our layers dialog. So with this layers option, I have the ability to change the base map. So I can change it to a satellite view, or I can set it back to our default. I also have the ability to change the opacity. So here I can change the opacity. If I do that along with the satellite view, you get a better sense of the context around the particular plume detection. I also have the ability to turn on some overlays. So I'm going to go ahead and turn down the opacity, and I'll first turn on our gas overlay. And this image here is what the plume image is actually derived from, and you can see how it lines up. The last thing I wanted to show is a measuring tool. So this measuring tool right here can be used to measure sort of from the origin of the plume out. And this is really useful for measuring the distance between the plume and a facility that would be maybe classified as like a sensitive receptor, like a population or a school. And we'll zoom back to the global overview. And I'm just going to walk you through some of our search capabilities here. So first things first, spatiotemporal filters like a date range. So I can filter emissions by observation period. We have our sector filters. So if you want to choose different sectors, here I'm selecting oil and gas and solid waste. You also have the ability to select the instrument. So we're adding new instruments over time, hopefully coming soon here. We have the Planet Tanager, but we also have some of our legacy instruments, as well as NASA's EMIT instrument. And moving further down here, we have the ability, obviously, to select the gas type. You can see that the different sources have different colors on the map. Also have the ability to change the emission units. This is really cool. Our default is kilograms per hour in methane or carbon dioxide. Finally, we also have the ability to list the units in thousands of cubic feet per day in gas. And this is a more common unit used in the energy industry. And then I have the ability to adjust source persistence. So persistence is kind of a key metric. This is the frequency at which a point source emits. And we define it as the number of plumes detected divided by the total number of overpasses. Okay, last filter to show is what we call our plume cluster distance. The minimum distance plumes would have to be from each other to be considered as part of the same source. Our default plume cluster distance is 500 meters for the solid waste sector. And for all other sectors, it's 250 meters. And I'm going to go ahead and zoom into this livestock facility in California. So this is a source with lots of different observations, and I think it's a good use case to kind of show what we call our source detail panel. First thing you can do here is I have a handy little link to open this same location in Google Maps. You can see the location of the source to sort of see what's happening on the ground. Coming back to the data portal, I can expand this top section here, and I can see the source name. So the convention here is basically the gas, the sector using some IPCC codes, and the cluster distance, which I mentioned before, 250 meters, and then the lat long. Sector is livestock, gas type is CH4, methane. So some of the headline numbers that we have at the top, once again, the source emission rate, which is the mean emission rate of all these plumes associated with the source, and then we multiply that by persistence. So take the mean of all these plumes, multiply that times 53%, and you get a source emission rate of 200 kilograms per hour. The total number of plumes you see here are 29 plumes across 19 days of observations. More plumes and observations. So you can see in the chart here, we have some detections all happening on the same day. So the y-axis is kilograms per hour, and the x-axis is date. You can see here in the plume details, we have the acquisition date and time, and the plume emission rate. So this is the emission rate for this particular plume. We also have, it's copyable, the plume name. So you can search based on that particular plume name or the lat long. We also have the sector, the instrument, platform, and then we have the acquisition date again, the date that we published it to the portal. That's kind of a key date. And then we have the wind estimate. And I wanted to show a feature we call summary statistics. It works in conjunction with our search filter. What it's doing is summing up basically all the point source emissions that you see in the view or that you've selected using your filters. So it's the sum of all individual point source emission rates in the field of view in kilograms per hour. This is helpful for just sort of trying to calculate I guess what you might call it like a point source emissions inventory. As you can see, as I zoom back out, majority of emissions here are coming from oil and gas sector. I can choose solid waste, or I can choose livestock, and you can see the share of emissions in that field of view. What's interesting here is you can also use this in conjunction with areas of interest. If I wanted to, I have this feature where I can search for a location. So you can see on the map here, I search for California and it creates an area of interest for me. And it's now going to constrain all of these point source emissions by that area of interest. So now 48,700 kilograms per hour, and you can see the share of emissions. Zoom back to the whole world. We have here on the left our downloads options. This is really helpful because it allows users to export lots of the data or all the data that you see here, different types of data, and use it in your own GIS systems or your own emissions management systems, and do further analysis and combine it with data that we might not have on hand. Okay, so that's our downloads. I'm going to come back to the coverage layer just for a second here. But if I zoom into a dense area, I'll go ahead and turn the clusters back on. I can click at any location, and I can get a list of all the active scenes at that location. So if you're trying to understand, how many times has a location been observed and what the dates were, you have that capability here. You can see all the individual dates. You can see the number of satellite observations, number of airborne observations. This can be done really anywhere. I have also the option of turning it on the ID of the scene, and then you can search based on that, or you can just look at the date as well. So that's our global coverage option. Definitely encourage you to take a look at our product guide. So this is a PDF document that provides an overview of the products that make up our data platform. So it includes a detailed description of each Carbon Mapper product, along with product uses, generation time, release latency, data format. It's a large document. Definitely take advantage of looking through it and understanding, our data and our how we develop our products and all the information associated with that.